Okay, so in this first video we're looking at Pythagoras' theorem, and Pythagoras was an ancient Greek mathematician, and I googled some pictures that were done, or actually some statues that were done, and he discovered an amazing relationship between the three sides of right angle triangles. So it's only to do with right angle triangles, no other sort of triangles. Okay, so put the heading in, don't need to draw the picture, and just come across and have a look what the theorem is. Okay, so with the right angle triangle, first thing you have to know is this little box in the corner indicates it's a right angle, i.e. it's a 90-degree triangle. Now, in terms of the theorem, you have to know one thing, and that's the side opposite the right angle is always the longest side. So the side opposite the right angle is always the longest side, and it has a special name called the hypotenuse. Now, to save writing out the word hypotenuse, we just use the letter H opposite the right angle, and the other two sides we just call A and B. Now, in some textbooks, they use the letter C, but I use the letter H. It's much easier to understand. So the H for hypotenuse, and then the other two sides are called A and B, and it doesn't matter which is which. One side's A and one side's B. So copy that down, all of that down, and then come across. And what Pythagoras found was this great relationship. Okay, so first of all, you identify the hypotenuse opposite the right angle, and the theorem is that when you take the square of the hypotenuse, it equals the sum of the squares of the other two sides. So the square on the hypotenuse equals the sum of the squares of the other two sides. Okay, and if you don't have H out the front, if you want to have A squared or B squared out the front, okay, you just switch the sides. So the B squared comes across to the other side by subtraction. So A squared or B squared, A squared equals H squared minus B squared, or B squared equals H squared minus A squared. And we'll look at some examples on how that's used. But copy that down and come across when you're ready. So here's an example of finding a missing side. Okay, so the first thing you do is identify what's the hypotenuse. So we look at the right angle and we go opposite, so that X is the hypotenuse, okay? Even though it doesn't have the letter H, it has a letter X, but the side opposite the right angle is the missing side. So if it's the hypotenuse, then we're going to sum the squares of the other two sides. So here's how we do it. So we've got X squared, the square of the hypotenuse equals the sum of the squares of the other two sides. So on your calculator, 3 squared is 9, 4 squared is 16, and you add those numbers together. Okay, and we don't want X squared, we just want X. So to get rid of the square, the opposite is the square root, and the square root of 25 equals 5, and the units are whatever the units are in the question. So the answer is going to be 5 centimeters. So can you copy that down, and then when you're ready, come across to the next slide. Okay, so let's look at another example. Okay, first step, look for the right angle. The side opposite is the hypotenuse. Now this time there's a number on the hypotenuse, so we're going to subtract. So this is like having, this is the A or the B this time. It doesn't matter which, it's the other side that's missing. So we have 13, sorry, we'll start, we'll do it the long way. So you could write 13 squared equals 12 squared plus X squared, but it's much easier just to go straight to, when you have the hypotenuse, it's going to be a subtraction. Okay, and then on your calculator, 169 minus 144, and again, by coincidence, that equals 25, just by coincidence. And so X equals the square root of 25, which again is 5, and the units are centimeters. So don't forget units. Don't forget the units. Okay, so on the next slide, come across when you're ready. So steps are, step 1 is find the hypotenuse. Find it, it's somewhere. If the hypotenuse is not known, then you have an addition. Okay, if the hypotenuse is not known, you're trying to find it, you have an addition. But if you know it, if you know the hypotenuse, then it's going to be a subtraction. Okay? Okay, it's always going to be a subtraction with the H being first. Copy that, come across. Okay, so we're on the last slide, and we're going to connect it with the previous topic on surds. Okay, so first step, there's the right angle, there's the hypotenuse. It's not known, so we have to do an addition. So x squared equals 6 squared plus 2 squared. 6 squared is 36, 2 squared is 4, so the answer is 40, and so x equals square root of 40. Now in the textbooks they might leave it like that, but you've just done a really short topic on simplifying surds. So 40 is 40 times 1, 20 times 2, 10 times 4, 8 times 5, and the only one that has a number that can square root is this pair. So we've got square root of 4 times square root of 10, so the answer is also 2 root 10 centimetres. So this answer is okay for some textbooks, but we would be hoping that you might simplify it down to 2 root 10 centimetres, because square root of 40 can be simplified. Okay, so there'll be an exercise either in the textbook or a worksheet on Moodle for you to have a look at for this one.